Hello, dear students and viewers and friends, both. So, today I want to discuss complex analysis CSIR NET 2023. So, friends, this questions was coming CSIR NET June month, and our examinations is now December. Yeah, that everyone we are all attending these examinations only for our knowledge, only for our only for enhance our knowledge. So CSR net questions are very interesting and knowledgeable. So friends, let's start to solve these questions. First is that let fz is equal to exponential z1 by z, the residue of f at z equals to 0. So friends, residue of f at z equals to 0 means coefficient. I have already discussed in my channel that coefficient of 1 by z. This is, you have to find out this portion. So now the question is e to the power z and plus 1 by z. So I can apply Maclaurin's theorem, but this is for easy for me that at first I break it in this way, e to the power 1 by z. Okay, so e to the power z into e to the power 1 by z means first formula is 1 plus z plus z square by 2 factorial plus z cube by 3 factorial up to infinity. Okay, this is the e to the power z, and e to the power 1 by z equals to 1 plus 1 by z 1 by z square into 2 factorial up to infinity. Okay, so let's start our multiplications. So we have to find out coefficient of 1 by z. So at first when I multiply 1 plus 1 by z plus 1 by z square 2 factorial up to infinity. Okay, let's another is multiplication. Okay, so 1 is multiply with this z we multiply. So first is z. Okay, second is 1, third is 1 by z to factorial. So friends, my interest is this value and this value. Okay, so z term is, I don't need, again I multiply with z square. So it is z square by 2 factorial plus 1 by z means when it is multiply, so it is z divided by 2 factorial. Okay, z square by 2 factorial and z divided by 2 factorial. Okay, and 1 by 2 factorial into 2 factorial, and next is 1 by 2 factorial into 3 factorial into 1 by 8. Okay, so on, proceed so on. So what we get, we see that coefficient of 1 by z, coefficient of 1 by z is equal to summation. Okay, summation n equals to whatever we see, L equals to L or n. Okay, however L equals to 0 to infinity 1 by L factorial into L plus 1 factorial, because friends you see that it is 2 factorial and 3 factorial multiply. Okay, 2 is in here L and L plus 1 you already see. So it is very clear and very simple. Don't need to know, don't need to explain so many things. It is the, what is the concept? Concept is key concept, coefficient of 1 by z. You have to find out coefficient of 1 by z. Okay, so let's go second questions. Second question is C be the positive oriented circle in the complex plane of radius 3 centered the origin. What is the value of the interval? This. So friends, this is my circle. this is my circle, okay, and I draw, let's draw a circle. Circle center is 3, okay, circle center is 3, and you get a lot of point, you can get a lot of point in here, no problem friends. But if you know the, what is the formula, formula is it is the very, it is, there is a lot of way, okay friends, because you see that our pole is, if pole z equals to 0, yeah, z equals to 0, double 0, another is z equal to 1 minus 1 0, triple 0 is my pole. So formula is, you know, that limit z tends to 0, 1 by 1, okay, and another formula is d square dz square, okay, z minus z cube, okay, z cube into, you can write 1 by e to the power z, e to the power minus z, sorry, it is not minus e to the power z, minus z, you can multiply, and after that you can use simple formula, okay. So if you apply this formula and z square is multiplied in here, if you apply this formula, you can solve this problem same way. So this is the one formula. Another is residue at infinity. You can use residue at infinity and coefficient of 1 by z, okay. So this formula is, another is residue due at infinity, it at infinity, there is a lot of process, okay, complex analysis. So sum of residue if z comma, okay, if zi, okay, equals to minus residue at infinity, residue f z at infinity, okay, you can get this way, okay. So friends, also you can check in my video playlist residue at infinity, yeah, you can get it, residue at infinity in complex analysis playlist, okay. If you do not find out, you can comment me, you can comment my sections, I will help you how, where I will give you links where I have discussed residue at infinity, okay. This topic is very important friends. So residue at infinity, this formula and this theory I have already taught, okay. So this way you can also find out. So let me solve this way, you can solve. So if you solve this way, so you can get 1 by 2 factorial, okay, 1 by 2 factorial, and limit z tends to 0, okay, limit z tends to 0, let me write, and z square, and this is the cut, okay. So you get d square into d z square z divided by e to the power z minus e to the power minus z, okay. So I think that this way is very large way, okay, 1 by 2 factorial, and limit z tends to 0, and you have to derivative this portion. So this way is very large in case of me, because double derivative of this, because you use chain rule and long. But if you solve this way, then it is very easy. So residue fz is equal to infinity, you can say residue fz at 0, okay. So residue at 0 is very simple, 1 by z. Okay, coefficient of 1 by z, I have already solved this portion. You see residue at 0 is equal to coefficient of 1 by z. So coefficient of 1 by z, if I apply in here, so whatever I get 1 by z square into e to the power z in the Taylor's expansion, 1 by z plus z square by 2 factorial and up to this infinity minus 1 and minus plus z. Okay, minus z square by 2 factorial. Yeah, this way you can. Now friends, you can write minus cut. So whatever I get 1 by z 1 by z cube into, okay, into 1 plus z square by 3 factorial. Okay, z square by 3 factorial up to infinity. Yeah, this is very simple, I think, according to me, and I just apply in here. Very simple, I just apply. Whenever I apply 1 by z cube into 1 plus z square by 3 factorial up to infinity minus 1. So you get the coefficient of 1 by z, coefficient of 1 by z is equal to 1 by 3 factorial. So my complex analysis value is equal to residue of a at infinity minus, so it is minus 1 by 3 factorial. Okay, so minus 1 by 3 factorial. So minus 1 by 3 factorial. 1 minute, another factor I have to check. Yeah, residue at infinity, z square and z square. Coefficient of 1 by 3 factorial. So what is my answer? Coefficient of 1 by z equals to 2 pi I into 3 factorial. Okay, so my answer is 2 pi I divided by 3 factorial minus 2 pi I 3 factorial. So okay, another factor is my mistake and my error is 2 is multiply. So in here when I added, so it is also multiply 2, so it is 3 factorial into 2 my residue, and my answer should be into 2 is equal to pi I by 6, pi I by minus pi I by 6. Please check my view. I just, okay, Please check. My next question is question number 3. Let D equals to Z belongs to C, mod of Z less than 1 be the open unit disk. Okay, very good. So number 1 is open unit disk. This is very important. And positively oriented boundary, positively oriented. Okay, this is important. And mod Z equals to 1. Okay, so open unit disk means it is positively oriented and fix a finite z1 z2 z3 belongs to D, and distinct points consider a polynomial zg gz is equal to this point, and degree n f be a holomorphic function. Okay, holomorphic function in open neighborhood of D bar. Okay, D bar means closed. What is the meaning of the D bar? D bar means D plus union. Okay, intersection, yeah, you can say union del D. Okay, del D means boundary. Boundary is also added, means closed set. Okay, so whatever they say that is defined pz is equal to 1 by 2 pi I c fj gj minus gz and j minus j into dj. Okay, so friends, you have to remember that which of the following are true. P is a polynomial of degree n, P is the polynomial of degree n minus 1. Okay, so we know the Cauchy's theorem. Okay, at first I have to discuss that P, okay, z1. Suppose I am putting z, so whatever I get 1 by 2 pi I. This is my formula, and closed integral f. Now I can write it is xi, you can say xi, and to gxi. Okay, gxi is no, it is also fine, and minus gz is equal to gz1, yeah, divided by xi minus z1 into gz1. Okay, so this is the formula, and d xi. So friends, this portion is 0. Yeah, obviously this is 0, and this is not z1, this is xi. So this portion is 0, so I can remove this portion easily. So this portion is not in here, and this is also g xi. So gxi cut, so it is 1. So whatever you see, we see that 1 by 2 pi I 1 by c fj into xi minus z1 into d xi. So friends, when we get this value, this formula is Cauchy integral formula. What is Cauchy integral formula, friends? Cauchy integral formula, note down, note Cauchy integral formula 1 by 2 pi I f fz. Okay, it is, you can write this way. My writing is not going good. Yeah, now we can write fz divided by z minus z0 into dz. That means it is fz0, and if it is the power of n plus 1 generalization, then it is fn divided by n factorial. Okay, this is the formula. I hope it is clear. I hope it is clear, because the Cauchy generalization. So my formula wise, I get f z1. If you put the value z2 z3 zj, then if you put the value z1 z2 zj, then you get this answer is correct. So similarly we can get pjj equals to fzj by the Cauchy integral formula. Now p is a rational function C with poles z1, z2, z3, zn. Now friends, we see that pzj is a polynomial is a function f as fzj is equal to pzj. So we see that suppose I can say, okay, f is holomorphic function, okay, no problem. So suppose fz is equal to constant function, okay, constant function, we can say open neighborhood of d bar, okay. So whatever I can say, okay, suppose fz is equal to z, yeah. So pz, how can we get the p is polynomial of degree n? It is not possible. And p is polynomial of degree n minus 1. This is not possible, okay. And another factor is that z minus z1, z1, z2, z3 both are point. Which point? Point of finite fixed point. And okay, so finite fixed point. So suppose fz is equal to, you can say 0. So you can say so pzz equals to 0. So what we can say, that fz is equal to 0, so pz equals to 0 according to the formula y. So how can we say that z1, z2 is the pole rational functions? No, it is not rational functions. Only option D is correct. Thanks for watching. I hope it is clear for everyone.